and some numerical problems also are there. We have to remember. So some formula will be there. If they are going in same direction, if they are going in different direction, okay. And some numerical problems are there. I think that will be completed today, right? So who is the presentator? Eunice is presentator. Eunice has gone out. Next, Sarvani, you come. You check. Must read. You must read that. Keep that like that.
Namaskar and very warm good morning to you all. As you all know, I am Sarvani Gautam from group Stephen Hawking, standing here to present on the topic force and motion. Slides are prepared by Eunice. So first of all, here is some biography of Stephen Hawking, which is our group's name. Stephen Hawking was born in January 8, 1942 in Oxfordshire, England, and he died on March 14, 2018. The place was Cambridge, Cambridge, uh, Cambridgeshire. Was an English theo- theo- theoretical physicist whose theory of exploding black holes drew upon both relativity the theory and quantum quantum mechanics. He also worked with space-time singular artists and singularities. Okay. So yeah, the first topic is what is reference point. A reference point or reference frame is a fixed point, place, object from which we compare the motion of an object. For example, we can talk the tree as a reference point of a reference frame for the bus as given in the diagram. So any fixed point, place, object from which we compare the motion of another object is a reference point or a frame. He also gave an example right here, and this bus can also be an example. So the next topic is relative velocity. The velocity of a body described relative to a reference point or reference frame is called relative velocity. When a car starts to move from a reference point such as G, the reference point does not change its position, then the distance or direction of both cars may change and each body is said to have a relative velocity with respect to the others. So, as here is the definition of relative velocity, the velocity of this point or reference frame is called relative. To be remembered, uh, if a car is moving in the direction opposite to another car, oh yeah, if a car A is, oh my god,
Maybe you need to read. Why?
sir, I didn't got the slide.
No,
You
slide
need-
you have to read the chapter.
You sent it and it was
It's
his
okay,
turn
but
to
you
explain.
need to read chapter,
Okay,
right?
sir.
Remember, you prepare the slides, but you must read, eh? You the presentator. Without reading, just coming blank is not okay. You also submit, is that clear? Karuna also remember. Eric also. Now there is one habit. One prepare the slide and rest of the relax. That's not way. Anybody can be called for presentation. That's why you must read yourself. Okay, what is here? At first, it was brought here reference point, right? Reference point. So, what is reference point? Actually, reference point is the fixed point or place or object. Now, here are some students outside. If they are compared with me, they are at rest. Compared with me means I am the reference point. Yes, sir. Like there may be one stick. In comparison to stick, whether the body is at motion or rest, accordingly we can compare. So reference point is any point or place or object. When we compare that house with comparison to that house, if somebody is running, then we can say the person is at motion. Yes or no? And so just anyway, it is fixed. It does not move at all. Position remains fixed. That is reference point or reference frame. Next one is relative velocity. What is here? Relative velocity. Velocity of a body which is compared with velocity of another body. If we compare two velocities, then what is it called? Relative velocity. Suppose, so if two velocities are compared, that is called relative velocity. One fixed point is here. This is reference point. A car or one person, he has got velocity, let's say VA. What is the velocity? VA. Or V1 we can say. Or can we say it? V1. Another person is here. Its velocity is V2. So are here two velocities or not? Now we can compare these two velocities. While comparing velocity, so which has got more velocity, which has less velocity, we don't know. Are they going in same direction or different direction? They are going in same direction. If they are going in same direction, then the relative velocity equals to which one is more? At first that one and another is second. So we have to what to do? Minus. We have to subtract. So but one body is moving in one direction, another body is going in another direction. In same direction, subtract them. In different direction, add them. So in different direction, relative velocity will be what to do? Plus. This thing we have to remember. Right? For example, one example let me give. Um, here is one fixed point. Okay, here is one fixed point. Fixed point is this one. So suppose A, what is here? B. So what is the velocity of A? Let's say 30 meter per second. How much? 30 meter per second. Velocity of B is how much? 20 meter per second. Then what is the relative velocity? How much will it be? So 30 meter per second plus 20 meter per second. How much does it come? 50 meter per second. If the bodies are traveling in opposite direction, relative velocity will be more. We have to add them, right? So suppose another example. One is moving with 50 meter per second. Another is moving with how much? 20 meter per second. Suppose velocity of C, velocity of D. So what is the relative velocity here? Which is longer? First write down that one. Are they going in same direction or opposite direction? Same direction. If so, come inside everybody. 50 meter per second minus 20 meter per second. How much does it come? 30 meter per second. Yes, sir. So, in this case, relative velocity is 20 meter per second. Is it okay? Got the idea? All right. So, whether they are going in same direction or opposite direction. Reference point, relative velocity, and so remember here say different or opposite direction. Relative velocity of AB is BA plus BB. In same direction, BB minus BA or BA minus BB. Which one is longer? Which one is shorter? We need to find out. Next one is, what is here? Acceleration. Okay, what is acceleration? If a body is moving with initial velocity, what is this? U. What are writing now? Initial velocity is how much? U. Final velocity is V. Velocity at the beginning is U. Velocity at the end is V. Right? If so, sorry? You come here, Moni. So Moni has got problem every time. So you make up. And why didn't you complete all your work on time? And you also don't complete your time. Why? What's the reason? Acceleration. Is here giving the definition of acceleration? Rate of change of velocity. What is that? Rate of change of velocity is acceleration. Acceleration equals to, what is the formula? What is the formula? V minus U by T. Relative velocity. What is the formula? V minus U by T. What is V? What is U? What is T? Time taken. Its SI unit is meter per second square. What is the SI unit? Meter per square. Okay. So initial, final. So for example, a body is traveling with velocity how much? 30 meter per second. What is the initial velocity? 30 meter per second. And its velocity changes into how much? 40 meter per second. Time taken is
5 seconds.
how much? 5 seconds. Then acceleration A equals to V minus U by E. Which formula is there? V minus U by E. What is V? 40 minus U 30 by 5. Now what is the SI unit? Meter per second square. 40 minus 30? 10 by 5 meter per second square. 10 by 5 means meter per second square. 2 meter per second square, right? In this way we can find out. What about the value of A? Positive or negative? What is the value? Positive or negative? Positive. So positive acceleration is that acceleration where final velocity is more than initial velocity. If initial velocity is less than final velocity or final velocity is more than initial velocity, then what is there? Positive acceleration. But if the final velocity is less than initial velocity, if U is greater than V or V is smaller than U, then the value of A comes Negative. So negative acceleration is called, find out, what is it called? What is negative acceleration called? Retardation. Is there retardation?
Yes.
Find out. Negative acceleration is called retardation or deceleration. Retardation or deceleration. Okay. So those things you have to keep in mind and remember. He has said, remember. Now here is don't forget. Good. Some new slides he has made. But he got punishment today. He hasn't completed work. Come here, you let the other people see your face. Hawkins. Stay there. Next time I will call you and show your face also. Belongs to Stephen Hawkins. Stephen Hawkins, one of the most famous scientists of this era. And memos are like this. Slide he has made very nicely. But work not completed. Everybody must complete the work. At first work, and second time, whatever is there, you can do it. Remember Hawkins. And next, which group we belong to? Newton. When is your turn? Tomorrow? No, he will do everything. Sunday. Oh, I already divided? Very good. So, remember, he has already said now, don't forget. What is given here? Don't forget. Please read here. B minus B. That means your velocity will be subtracted. Don't forget this one. Very good. Next, what is here? Acceleration already we have discussed, right? So, how many more slides are there? Here is one formula to calculate acceleration. We have already said. Did I say to pay attention or to write? Then when there was time, you are not writing. V minus U by T. SI unit is meter per second square. And what did he do? So he has made a unit of acceleration. So meter per second square. So actually, he has mentioned here two types of acceleration: positive acceleration and negative acceleration. Up to here is completed. In book, up to which page number is completed? Let's take one. Now your note must contain these things. So mark it and first complete your work. Page number is page number. Okay, this one. This is the one. What is the reference point? Page number 144, 45, 46, 47, 48, 49, 50. How to 49? How to 49? 44 to 49. 44 to 49. You start doing your work and Niranjan, you collect the copies right now. I will check everyone's copy. So students.